Hello pre-calculus and welcome back. In this video, I'm going to walk you through how you can start with the graph of an exponential function, and you can take that graph and use it to write an equation. So this is an example from your Lumen textbook. They give you the answer, but they don't really go through how to solve this one. So I thought it would be nice if I showed you guys what to do here. So the pattern we've used in the past, the thing that we always start with is we start with our generic exponential function. We know that exponential functions look like this. A times b to the x power, where a is the initial value, b is the growth factor, and x is our variable. Usually, our variable has to do with time when we're talking about exponential growth, but not always. And there can be other kinds of exponential growth that aren't looking at time. So we're going to start with our generic function here, and then we're going to use the graph to fill in our values of a and b. We're going to do a little magic here. So one thing that's important to know is that the initial value, what that really means, what the initial value is what value the function has at x is equal to 0. So another way you can think of this is when x equals 0, what is f of x? And if you look at our graph here, you can actually read that value out. So take a look at our graph, what we have here. When x is equal to 0, we get this point, which is very helpfully labeled for us, 0, square root of 2. So our initial value here is the square root of 2, So let's go ahead and plug that in. We're already well on our way to finding this equation. So now we have f of x is equal to the square root of 2 times b to the x. And we still need to find, let's highlight it in red, we still need to find that growth factor. How can we do that? So what we want to do is we want to find another point on the graph and use that and plug that in to solve for b. So let's take a look at this graph here. We want to pick a point on our graph that's going to be nice and easy for us to work with. And so what I'm going to do is I'm going to look and I'm going to give us some points here in red. So I think here are some choices of nice points that I might want to work with. Because when I look at the graph, I can read here that this is my point 1, 2, and this is my point 3, 4. So I'm basically choosing points that have integer values so that when I'm plugging them into my equation, they're easier to work with. I mean, technically, you could use this point on the graph, but then we'd have to decide that's 2 and some change. We'd have to estimate what that change is. So I think it's easier to work with a point that's an integer value. I'm going to choose to use 1, 2. But you could choose either one of these points and theoretically you'd get the same answer. The decimals might be a little different due to rounding, but you could choose either one. I'm going to choose 1, 2, and I'll show you how that works. So I'm going to choose to use that point, 1, 2, and I'm going to plug this in so that I can solve for b. So 1 is my x and 2 is my f of x value. So what I'll do here is I will take 1 and that will be my x. So I know that my function will be equal to square root of 2 times b to the 1. That's my x value. And then my f of x is equal to 2. So I'm going to take my f of x and I'm going to replace that with 2. So now I have 2 is equal to the square root of 2 times b to the first power. And I can just solve this for b at this point. I can divide each side of this equation by square root of 2. And these cancel. And so now I'm left with b is equal to 2 divided by the square root of 2. And you can punch that into your calculator if you like. I'm just going to leave it as is because I don't want to round. So now my final version of this equation will be f of x is equal to our a value was the square root of 2. Our growth factor is 2 divided by the square root of 2 raised to the x power. And that's how you can get the equation just by reading the graph. I hope that was helpful for you guys. Stay safe out there. Keep working on those lumen problems. And I will see you in the next one.